I want to talk really quickly about how to use the package symbol wizard to design a footprint really quickly in Cadence. So the part I'm going to be designing for is this op amp. It's a TL972IP op amp from Texas Instruments, and I went ahead and pulled up the data sheet here, and I looked for a recommended footprint layout, and I didn't see one, but I did see this drawing of the device right here. That we can kind of use to answer some of the questions from the wizard. So let's go ahead and start by doing File, New, and then we can select a new package symbol wizard, and we can name it the name of the part. So I'm going to name it TL972IP. And I'm going to make sure I put it in my Cadence symbols directory, and then I'll press OK. And it's going to ask me to select the part type. You can select all of these different kinds of parts and see a preview of what they look like. This part is a dual inline package or a DIP or a DIP package. I press next, and I can try to go next, and it's going to make me hit load template. So I just hit load template, and then I can hit next. I'd recommend you leave all your units in mils. That's usually the best policy, so you can keep track of everything. I'll just press next. It's going to ask me the number of pins. This is an 8-pin device, according to the data sheet, so I'll just bring this down to 8. It's going to ask me the lead pitch. It's already preset at 100 mils, and this is a standard, so I would expect to see this on the data sheet as well. And I do. It's 100 mil spacing right here. So I'll leave it there. And then this terminal row spacing E1 is on the picture is also a standard. So I can look at that on the data sheet. I should see that as well, and I do see it here. So I can leave it at 300, or I might increase it to 325 if I want to make it a little easier to put this to put the part in, so I don't have to bend the pins in as much. I might increase that to 325 mil. It's not that big of a deal. I wouldn't go so far as to make it 430 mils apart. That's pretty far, and you might have trouble getting your part into the board. Package width E, we can get that from here. It looks like it's about 260 or 240. I'll use 240. I'll split the difference. I'll do 250. 250 is already preset there. The package length D is how long the package is, and it looks like I'm going to put that at about 400 mils. So then I can just go ahead and hit next, and it's going to ask for the default pad stack to use. So I can select an existing pad stack. Cadence provides a lot of different default pad stacks that I can use, but it's really not too difficult to create your own pad stack from scratch so you know exactly what's going on. So I can do that if I go ahead and open up the pad stack editor. And I'm going to go ahead and start just making the pad stack that I want to see. So first I'm going to make it an octagon just because I think they look pretty cool. And it is going to be a through pin device. So now I'm going to look at the drill size. And to do that, I'm going to open up the data sheet, and I'm going to look at how wide this pin is. And this pin is about 21 mils wide. So I want to make the drill size significantly larger than that so that the pin can go through the board without any trouble. So I'm just going to bring this up. I'm going to say like 40 mils might be a good drill size. And that's kind of a judgment call more than anything. You can do a 40 mil drill size and make sure it's a circle. And then, so that's describing the hole. We'll also set the drill symbol, and this is just a symbol so you can see what it is. I like to use squares, but we'll make it the same size as the drill, the 40 mils. And now we're going to go over to design layers, and we can actually design the copper. And this red circle here is just the hole, and now we're going to design the copper that goes around it. So I'm going to design it as an octagon, and I'm going to do maybe so the 40 mils is the hole. I want to make the copper that goes around it a little bit bigger than that. I'll try 80 and see how that looks. It looks a little bit like there's a lot of copper, so it might have some conflicts. So I might do 70. I might even do 60. I'll probably do 65. And I'll also do it on the end layer as well. So 65 there. And I'll also do octagons for the solder mask layer. And then I'll go ahead and just save this pad stack. So I'll do File, and then I'll do Save. And it says no default internal pads are defined. So this problem is not really a big deal. All it's telling me is that if there are internal pads, then they're not going to be defined. So I can define an octagon on the internal layer as 65 mils, and that should correct that problem. So I'm just going to save it with a prefix underscore so that way I can find it easily, and I'm going to call it something that I can something that I know what it is. So this is an octagon, and this is a 65 mil octagon with a drill size of 40 mils. I think we made it. Back to my package symbol design now, I can select my pad stack and I can scroll to the bottom and I can see the pad stack we just made because we prefixed it with an underscore. Then I'll just hit next, and this is one problem that you should really, or this is one important part that you should pay attention to. You have to select pin 1 of the symbol because this is typically how the device is numbered in the data sheet. You can see this is 1, 2, 3, 4, 5, 6, 7, and 8. So we want to make sure in the package symbol wizard that this pin 1 starts at the top left and not in the center. If you do center of the symbol body, it'll put the pin 1 kind of in the middle here. So make sure you do pin 1 of symbol, and then it can create a compiled symbol. That's fine. And we'll just press next and finish. And we should see the device that we've designed populate here. So that's how you make a simple footprint with the package symbol wizard. I hope that was helpful.